mind, can you stop playing the music? I'm recording and it's so loud.
Assalamualaikum and a very good evening to the panels, Dr. Syamihayan and Dr. Zamri. You are watching a video presentation by Nur Hidayah binti Ahmad Syafi'i entitled Lepironia articulata as a sustainable acoustic absorber. This research was supervised by Professor Madya Dr. Muhammad Hafiz bin Zainul Abidin.
Hi everyone. Sorry for the drama just now. You must feel the same around loud noises, right? If so, you are probably experiencing the effect of noise pollution. This is your lucky day because today we're going to talk about sound, noise, the effect of noise, and how to reduce it. So without further ado, let's begin our presentation. Sound plays a significant role as a communication medium to manifest emotion or as a signal to indicate danger. However, never-ending urbanization and industrialization cause noise pollution to increase prominently. What exactly is noise? Noise is an unwanted sound that is unpleasant to human ears. Yes, it is true that human ears are designed to hear a sound, but a continuous exposure of a sound more than 85 decibels will lead to hearing loss and a range of non-auditory effects such as mental health, stress, communication difficulties, and also a rapid heartbeat. Alright, so now you have know the effect of noise disturbance, but what are the steps to reduce it? The simplest method to reduce the noise disturbance is by using sound absorber. The advantage of sound control by using acoustic material is its capability to reduce echoes, reverberation, and sound resonance. By decreasing noise, it will directly enhance the interior environment of a space, increase privacy, and improve productivity as loud noises often distract people easily. Due to the limitation of the natural fibers such as low thermal stability, high water absorption, and poor durability, the acoustic performance of the natural fiber as a sound absorber must be identified. In this study, we are investigating the acoustical performance of a type of a grass that grows wild in a swamp and along the stream named Lepironia articulata, which is also known as kercut, kumbuh, burun, and burun danau. It is commonly used as a filtration media in grey water treatment and a material to make a wide range of craft by a local in the Tasik Chini, Pahang, and also Setiau Terengganu. It slowly gains attention when a Vietnamese entrepreneur starts to promote it as a biodegradable straw. It has various of benefits and might be useful as a soundproof material. Unfortunately, there's a scarcity of knowledge on the physical and acoustical properties of Lepironia articulata. Therefore, the potential use of Lepironia articulata as a raw material for sound-absorbing material must be identified.
The objective of this study is to fabricate sustainable acoustic absorber, to investigate the performance of sound absorption, and to determine the significance relationship between the physical and acoustical properties. For the scope, there are 6 scopes in this study.
The use of Lepironia articulata as a filler for sound absorption can further utilize the potential of these resources as it found abundantly in West Malaysia. Furthermore, this research may help to provide alternative natural filler for sound absorption to substitute the expensive synthetic fiber. So in terms of sustainability, there are 4 SDG according to the United Nations in this study. Since Lepironia articulata often grow wild in a swamp and along stream, they are usually cut down and burned as they don't have a significant benefit. Therefore, it can be incorporated as acoustic material instead clearing the waste via burning. In terms of environmental sustainability, the production of sound absorber using Lepironia articulata will reduce air pollution and produce lesser greenhouse gas and carbon dioxide gas emission levels. As I mentioned earlier, synthetic sound absorber are usually expensive. Therefore, in terms of economic sustainability, these hold great benefits in reducing the production cost due to their abundance and low-cost manufacturing process. Thus, it will eventually decreasing the cost of buying sound absorber. Last but not least, in terms of social sustainability, the usage of Lepironia articulata as a sound absorber will help to unlock new market, attract investors, and improve the living standard of the locals by creating a stable and secure income.
Next, I'm going to talk about some of the literature review in this study.
As we can see here, fiber can be classified into two categories, which is natural fiber and man-made fiber. So previous research was done by Ikushima and Yasmin. They said that Lepironia articulata is one of the most primary producer in a large tropical swamp in West Malaysia, especially along Tasik Bera and also Tasik Cini Pahang. However, it is often damaged and burned by people due to turtle hunting and clearing the plant. Typically, Lepironia articulata has a hollow stem, fibrous root in a white to brown color, and a brown seed at the end of the shoot with a long straight stem. It is a highly ornamental plant. According to Omar, the stems are commonly utilized for a traditional basket making, mats and bags by locals in Tasik Bera. These are the factors that influence the properties of sound absorption. The density of a material increases up to a certain limit as the fiber content per unit area of the material increases. Acoustic absorption performance is higher for a denser material due to an increased frictional surface between the acoustic wave and the fiber. As the density decreases, the porosity of the material will increase, resulting more sound attenuation. There will be ineffective absorption if the material is too dense because the wave is difficult to penetrate through the material, and inadequate frictional resistance between the vibration of the particles and the material. By introducing the air gap will eventually increase the thickness of the panel. Thickness of porous material have a direct correlation with the absorption of sound at low frequency but less effect at higher frequency range. Tortuosity indicates the time needed for the penetration of acoustic wave through the material. The more difficult distance traveled by the acoustic wave causes the material to have a lower sound absorption coefficient because of the losing energy as they spend more time in contact with the medium. Flow resistivity happens due to boundary layer effects within the absorber. So in this research, the sound absorption coefficient and noise reduction coefficient are investigated to determine the acoustical performance of the Lepironia articulata. SAC and NRC might sound the same, but it is not. Okay, actually, NRC is a single number that is used to determine the effectiveness of sound absorption material. We can actually get NRC after we have determined the SAC using a method such as impedance tube method. Okay, the flowchart of the methodology in this study is as shown. In order to achieve the first objective, there are 4 phases, which are mold preparation, material preparation, pre-treatment and sample preparation. Mold size with a diameter of 28 and 100 mm were prepared to ease the fabrication of the sample. Next, we need to prepare the fiber and the sodium hydroxide solution. In the fiber preparation, the wild grass was harvested, weighed and washed under a clean running water to remove impurities and dirt. The hollow stem was cleaned using a straw cleaner brush. In this study, we are using 4% concentration of NaOH since research done by Kartikeyan in 2014 revealed that alkaline treatment using 4% of NaOH is recommended as it will cause less damage on the fiber surface. In order to prepare 1 liter of NaOH solution with a concentration of 4%, 40 grams of NaOH is needed to be diluted with 1 liter of distilled water. After we have done preparing the fiber and also the solution, the Lepironia articulata need to undergo pre-treatment to enhance its properties. The clean fiber was dried for 2 days before soaked with 4% of NaOH solution for 6 hours at room temperature. This is to make the solution totally absorb into the fiber. The last phase of the material fabrication is sample preparation. There are 4 different arrangements in this study, which are vertical, angle, double and zigzag as shown in the figure here. All the arrangement of the sample were prepared for 2 sets, which is for a diameter of 28 and also 100 mm with a constant thickness of 50 mm, since according to the ultimate guide to acoustic panel for home recording, 50 mm of thickness are categorized as industrial standard panels. Lastly, air gap of 50 mm is introduced for all the samples before we do the testing. Moving on, we will conduct a testing procedure using a independent strip method based on international standard of ASTM E105098 to achieve our second objective. The software of SCS8100 was installed in the operating computer system and connected to the test tube will generate the output signal graph of sound absorption coefficient against frequency. From this graph, we are able to calculate NRC by taking the average value from the sound absorption coefficient of the sample. The density of the sample were determined using a density apparatus made by method Toledo as shown. Meanwhile, the other parameters was determined using the equation as shown. Based on the testing that have been conducted, the acoustical performance of the Lepironia articulata were identified. In the next stage, the sample recorded the highest SAC and NRC will be identified. Then we will evaluate the significant relationship between the physical and acoustical characteristic to achieve the last objective, which is to determine the acoustical performance of Lepironia articulata.